Hey everybody, thanks for watching. In this chemistry lesson, we'll be practicing drawing the atomic structure of some simple elements. We'll start with these two. We'll draw a boron atom and then a carbon atom. If you think you can do this on your own, feel free to pause the video and then I'll show you the correct way of drawing the atomic structure. Okay, here's how we'll draw a boron atom. There's lots of ways of drawing atoms. Our main interest right now is in correctly arranging the electrons in the electron shells. So rather than drawing the entire nucleus of a boron atom, we're just going to draw a red circle with the letter B. B is the element symbol for boron, so we know that this is the nucleus of a boron atom. The element boron has atomic number 5, which means there's 5 protons in the nucleus. And if the atom is neutral, then it will have 5 electrons configured in those shells. So we'll start with shell number 1, and we need 5 total, but shell number 1 can only hold 2. So we'll draw 1 electron, then another electron. So what do we do now? Now we have to draw the next electron shell and draw 3 electrons in shell number 2. And here we have the correct illustration of a boron atom. So we have 5 total electrons that go with each of the 5 protons in the nucleus. We've drawn 2 electrons in shell number 1 and 3 electrons in shell number 2. Now we'll draw a carbon atom. Just as we did with the boron atom, rather than drawing the entire nucleus, we're just going to draw a red circle with a C in the middle. That's one way of abbreviating the nucleus of an atom. We know that carbon has atomic number 6. That means if we did draw the entire nucleus, we would draw 6 protons, and in order for the atom to be neutral, there also has to be 6 total electrons. So in shell number 1, we will draw 2 total electrons. Again, because that's the maximum number of electrons that can be contained within shell number 1. Now we'll draw shell number 2. To get up to 6 total electrons, we'll need to draw 4 more electrons in shell number 2. Now we have 6 total electrons, 2 in shell number 1 and 4 in shell number 2. So this is one way of illustrating the atomic structure of the boron atom and a carbon atom. Let's try 2 more elements that are slightly larger, the nitrogen atom and an oxygen atom. If you think you can do this on your own, feel free to pause the video and then I'll show you the right way of illustrating these. Just as we did before, we'll abbreviate the nitrogen nucleus just by drawing an N inside of this red sphere. We know that nitrogen is atomic number 7. That means there's always going to be 7 protons in the nucleus, and if the atom is neutral, that means there'll be an equal number of electrons in these electron shells. As always, we'll start by drawing shell number 1, which contains a maximum of 2 electrons. Now we'll draw shell number 2. We need 7 total, which means we need to draw 5 more because 2 plus 5 equals 7. And we're not breaking any rules because shell number 2 can hold up to 8 electrons total, but we only need 5. So here we have a correct illustration of a nitrogen atom. We have 2 electrons in the innermost shell, that's shell number 1, and 5 total electrons in shell number 2. We haven't broken any rules. We only have 2 in shell number 1, and we still have not exceeded the maximum in shell number 2. Now let's draw the oxygen atom. As we've been doing, we'll just draw a red circle with an O in the middle because O is the symbol for oxygen. Oxygen is atomic number 8. So eventually we need to get up to 8 total electrons in these electron shells. Shell number 1 will have 2 total electrons, and then we need a number of electrons that gets us up to 8. 2 plus 6 more electrons will give us 8 total. So in shell number 2, we can draw 6 total electrons, which will give us a neutral oxygen atom. That means we have equal numbers of protons and electrons. So we've got a nitrogen atom and now an oxygen atom. Now let's try 2 additional elements, neon and sodium. Try to pause the video and do these on your own, making sure that you know the atomic number for these elements so that you know how many total electrons to draw in the electron shells. If you looked at your periodic table, you know that a neon atom has 10 total protons because its atomic number is 10, which means when it's a neutral atom, it will have 10 total electrons. So that's what we need to draw. We'll start by drawing the neon nucleus like this, just a circle with Ne inside because that's the atomic symbol for neon. We'll draw shell number 1 with 2 total electrons. Then we'll draw shell number 2. In order to get up to 10 total electrons, we need to draw 8 more here in shell number 2. And that's all we have space for. So with this neon atom, we will draw 8 additional electrons in shell number 2. So now we have 2 electrons in shell number 1, 8 total electrons in shell number 2. We've maximized the space in both of those electron shells, and we have 10 total. And here's something really interesting about neon. Neon is one of the noble gases, and the reason it's special is because it has a full valence shell. It has 8 total electrons in the outer shell, and in chemistry, that's good because neon is very satisfied. It's a happy atom, and it has no interest in interacting with other atoms. It doesn't want to give away any of its electrons, and it doesn't want to gain any additional electrons because it has exactly 8 electrons in its outer shell. That's why it's called one of the noble gases or inert gases, because it's not very inclined to interact with other atoms or other elements. Now let's try drawing the sodium atom. Sodium is interesting because it's a little different than the elements we've been drawing so far. It starts out the same though. We begin by abbreviating the nucleus just with a red circle and Na in the middle. That's the symbol for sodium. We know that the atomic number of sodium is 11. So there's 11 protons in the nucleus, and if the sodium atom is neutral, it'll also have 11 total electrons. It doesn't always have to have 11 total electrons, but if it's neutral, if it has equal numbers of protons and electrons, it'll have 11 electrons in these shells. So we start out with 2 electrons in shell number 1 because that's the maximum it can contain. Now we'll go out to shell number 2, and we will completely fill shell number 2 with 8 total electrons. And you remember shell number 2, it can only hold 8 total electrons. So now we're at the max of shell number 2, but we're only at 10 total electrons, which means we have to now draw shell number 3 with 1 more electron. So this is what the atomic structure of a sodium atom looks like. It includes 3 electron shells, 2 in shell number 1, 8 in shell number 2, and 1 more electron by itself in shell number 3. And this is what makes it very different from the neon atom. Neon has 8 electrons in its outer shell, so it has no interest in interacting with other atoms. Sodium, though, is exactly the opposite. It only has 1 electron in its outer shell, which actually makes it extremely unsatisfied and very reactive. Keep that in mind because we'll discuss that in future lessons. Thanks for watching, and as always, if you have any comments or questions, drop those in the comment section below. Thanks.